Now, when we talk about big data, we like to think about Amazon and Google and all this stuff, but the truth of the matter is, even us small guys generate a lot more data than we used to. And the challenge is, how are we going to keep that data not just stored, but how are we going to access it for all the reasons we're going to want to get to in a second? How can this help us with our business? How can this help us, predict churn? How can this help us comply with subpoena requests that are coming from the FBI or wherever? And the truth of the matter is that a lot of us got comfortable with this for a long time, this kind of thing that you buy at Best Buy. Even 200 gigabytes is no big deal. You can put this in your drawer once a year and say that you have a backup strategy. But you're not really backing it up in a place where you'll be able to get at it quickly and trial and error new thoughts about algorithms and things you want to look at to get a sense of what's really happening in your network. So we've gotten away from this. I mean, Hurricane Sandy taught us a lesson that some of these were on the ground and we could have lost them and if the water came in. And just when we think about redundancy, we're not thinking about it at the scale that these big providers are. They think about it at a totally different level. So I would say avoid the so-called Best Buy solution and start to think about exactly how much data you are generating in your networks. And this is just call detail records, which we'll spend a fair bit of time talking about. But your billing data, your network data, your provisioning data, all the metrics that all your nodes are generating, all of that can be captured and put to good use. So let's talk about redundancy for a minute. Us mere mortals think having two of these would be lots of redundancy. It isn't. One of the reasons to outsource this, and it's very, very cheap, you can store about 200 gigs for about $10 a month. These people, where you're storing it, are thinking much longer term, much larger scale than you and I are. They're actually they're replicating this data across different data centers that are on different continents, that are on different, within the continents are on different geological plates, tectonic plates. If there's an earthquake in one zone, your data is safe on the other. It's just not the kind of thing that any of us here should really be worrying about, or could, if we devoted all our time, could come close to. We're in the business of telecommunications. It's our opinion it's better to let some of this go to the people who can worry about this the most. Funny story, a few years ago, or when industry got started, even say 100 years ago in this country, there were people who were vice presidents of vice presidents of electricity, and their job was to make sure that, take the Corvette plant down the road, if it didn't exist 100 years ago, but if it had, their job would have been to make sure that there's electricity on the plant at all times. And there were people, the whole departments that kept that generation system working. Today we think of that as sort of outdated because after all we have a grid and you expect it to plug in and get all the electricity you want and have it be metered. One of the views about this whole big data revolution is that we're going to see in the future, we're going to start to think of computing power in the same way. Just as we think it's kind of outdated to have electricity to be something that you worry about, generate on your own facility, other than when Hurricane Sandy's come through your backyard. But other than that, we're going to start to think about computing as something that's more of a grid-based thing. We just rent when we need to. So, a few of the myths. There is no cloud, really. As anybody who works in the telecom industry knows, there's no such thing as just a squirrely cloud that you draw and arrows come in and out of. There's real hardware behind this. And the people that we'll rent this from, and I'll kick off a big cluster in a minute for you, they do have those data centers, the kind we showed at the beginning. The kind we don't have, but they have. There's no such thing as just big data leading to all kinds of insights, right? That's one of the things you see on TV a lot too. That, big data will mean I have all kinds of insights. All the insights that we've ever seen really come out of small and medium data. I mean, at the end of the day, the business decisions you're going to make are coming out of things that would fit on a laptop, not a server. But you have to get there first. So big data allows you to crunch down your data into these meaningful data sets and do it in a way that's cheap and it isn't expensive. The idea that it isn't secure, the best thing you can say about that is that even the Central Intelligence Agency is starting to use public clouds for this stuff. And they believe so much in this that it's secure. I hope it is. That all of the data you store in the cloud, it can be encrypted, which means that the data is not accessible to anybody else, even if they could get their hands on the data, right? If I encrypted every piece of information with strong encryption and put it on this disk, it wouldn't really matter if I forgot the disk and left it in the hotel here, because you could get at it, you could see there are files in there, but you wouldn't be able to read them. So the idea that your data rests encrypted is baked into all this cloud stuff. So you can confidently put data up there, and even Amazon can't get at it. And they wouldn't want to anyway, or Google wouldn't want to anyway, because they've built such a huge business around this. And incidentally, I mentioned the big cloud providers, but this could be, we got started with big data. Yes, sir. It's nothing about this makes insights easy, but at least it allows, we like to say, drops the cost of failure down. Right? So if you have a theory about if your customers are leaving because your competitors have a better offering, or if you have a theory that says your customers are leaving because they're interconnected with people who have already left, this allows a platform where you can experiment with those ideas. But it doesn't mean that you just throw everything in and out comes your answer. It also doesn't mean that insights are easy. I'll leave you with this for a second to think about this. Even here, CNN probably have an army of data analysts, but they put up ridiculous graphs like this. You know, which side has less than a 50% chance of happening? Right? You can crunch a lot of data and still come back to something that's nonsensical. Okay, so there's no built-in protections against stupid graphs at the end of statistics, right? It can also mean kind of the inane gets explored. Here's a graph, James Bond fans of, this is by no means big data, but it's sort of humorous, that they rank the different actors who played Bond over the years by kills, conquests, and martinis. So if you were wondering, it seems like Pierce Brosnan's did well in the kills department when he was on screen, but martinis-wise, that's still Sean Connery and Roger Moore who would lead the pack. So it can be humorous. Doesn't necessarily mean every bit of data you're going to find in your analysis necessarily is earth-changing for your company. That's my point. So we had two. When we decided we wanted to get into big data, we had two paths. And our first cloud, if you will, was in that data center I showed you, the Mesa one. And we built 10 of our own servers out of our own CapEx budget. We bought them, installed them, racked them, had to put in a new air conditioner, the whole 9 yards. We had to maintain and patch them. Sir, as you pointed out, we had to patch them all the time to keep the hackers at bay. We had to jostle data to the right server at the right place at the right time, the equivalent of moving this around the room to where we needed it most. And we ran multi-day jobs when they were needed, but a lot of the time they were sitting kind of idle. And while they were sitting idle, we wanted to make sure that not too many people used them because we might need them again. But we had a lot of slack time between these spikes. So that didn't really work for us. What we decided would be more helpful would be to light up, say, 50 or more servers as needed, and only when we needed them. Sometimes we're running jobs that are 50 servers strong and only running for a few hours. And then when we're done with them, we release them, and we've paid a few cents to borrow them, if you will. The data is already in position and ready to go because we're not using these anymore. We're storing the data securely up in the cloud, and we're lighting up computing capacity around the storage where it's readily accessible. We're not plugging USB cables into the nearest machine to run it. It's all accessible. And we're running, as I said, we're running a job and then we're turning them off. And we found that over time this has been much cheaper to us and much more effective. And we get jobs done a lot more quickly.